Hi everyone, so in this video we're going to be explaining depth first search, also known as DFS, using this tree diagram, and we'll also compare it to breadth first search so you can clearly see the difference. Depth first search is an algorithm used to traverse or search through trees and graphs. So the key idea behind DFS is very simple: go as far down as possible before coming back up. So let's start with the tree on the left side of the diagram. We begin at the root, which is node 1. From there, DFS chooses one child and follows at the path downward as far as it can go. It doesn't look at the other options yet, it commits to one path. So starting at node 1, DFS goes down to the left child, then keeps moving down to the next child and continues this process until it reaches a node with no children. That point is called a leaf node. So let's look at an example. So here it selects A, and then from A it goes to B and H, and then it determines which one to go with. So it will go with the left child and select B. From B it'll look at C and E, and from here it'll select C, and then from C it'll go straight down to D because that's the only path, and then it'll backtrack up to B, go to E. From there it'll go from F and G, it'll go with F, and then after F it'll select G. It'll backtrack all the way up, and then it'll select H, and then after H it'll select I, and then after I it'll select J or K. It'll go to the left child first, which is J, and then go up and then select K. So here on the right, breadth first search moves through the tree level by level. It starts at the root and then visits all the nodes directly connected to it before moving down any further. So in the diagram you can see BFS spreading across the tree horizontally instead of following just one deep branch like DFS. This means it explores all nearby nodes first, so rather than going deep immediately, which is what makes it different from depth first search. So when we talk about the big O for depth first search, we're describing how efficient the algorithm is as the size of the graph grows. For DFS, the time complexity is O of V plus E, where V represents the number of vertices or nodes and E represents the number of edges or connections between the nodes. This is because DFS visits every vertex once, and it also explores every edge once while moving through the graph. Even though DFS may go deep along a single path, it never visits the same node twice. So no matter the shape of the tree or the graph, DFS will always scale linearly with the total number of nodes and connections, which makes O of V plus E its overall time complexity.